What exactly is the James Webb? And why has it been causing such a stir everywhere for the past couple of years? Fascinating an ordinary person with its power? In today's video, you will know everything. If I say that the James Webb can take you into the past, can make you time travel, then that is absolutely not true. But if I claim that the James Webb can literally show you the past, what ancient times were like, what the creatures were like, what the environment was like, this is absolutely true. The James Webb can do this. Our universe started 8 billion years ago, when Big Bang happened. And James Webb can look 13 billion years ago, just 8 years. We are far from the creation of universe. Thing that make James Webb unique and powerful is its ability to capture infrared rays. Let me clear it first. You've probably all heard about the electromagnetic spectrum. Basically, what is it? It's quite a large spectrum on which we have different light waves, such as radio waves, microwaves, ultraviolet waves. Among these, there's a portion for visible light, which we humans can see with our naked eye. That light. Basically, the small telescopes, like the ones we use in our regular routine, work on the principle of the visible light portion. And with its help, we can see the things we want to observe. The range from blue light to red light is what we basically call visible light, and the red light has a relatively large wavelength. Here, one more thing is that frequency and wavelength have an inverse relation. I will explain this to you with an example. You are listening to the radio from a station far away on your phone, hearing the program, music, or whatever is being broadcast. Despite the kilometers of distance, the audio reaches you clearly, and you can hear it without interruption. This happens because radio waves have very large wavelengths, spanning many kilometers. That's why they pass through buildings and everything else to reach you, delivering the sound you are hearing at that moment. If you heat food in a microwave, it takes less time because the microwave heats it up quickly due to its higher frequency. It's not like you take the food out of the microwave and heat it somewhere else. The wavelength is shorter, but the frequency is higher. Now, why did I talk about all this? Look at these pictures. One is taken by the Hubble telescope, and the other by the James Webb telescope. You can see the difference between the two pictures. The James Webb is providing more details because it has the ability to capture infrared, and it can see across all these gases, but the Hubble doesn't capture infrared. For these reasons, Hubble, that was one of powerful space telescope, was replaced by James Webb to capture infrared. And you people must be thinking here, what's the impact? The impact is clearly you have seen with these pictures that James Webb can see across these gases and clouds. Because of this, it will provide a better quality and more details. James Webb is placed 5 million kilometers away from Earth, and one of its drawbacks or risks, which you could say, is due to this reason. And what is that reason? Let me tell you. This 5 million kilometer point, which is far away, is called L2, and it is placed at this point so that it can be protected from the heat of sunlight. There is also a reason for this. When a body releases heat, it also emits infrared at the same time. Similarly, when a planet or star releases heat, it also emits infrared rays, and then James Webb capture those and send them to Earth. Here a problem arises for the scientist, and the issue was that just as everything releases heat, similarly, James Webb could also release heat, and then it was also being protected from sun heat. But when it itself releases heat, it would also produce ultraviolet rays. Because of this, it could cause problems in capturing the image and affect its quality. For this reason, an important step was taken. First, this is working in the temperature of -233 Celsius. And the other thing might surprise you because hundreds of millions of dollars were spent on it. And that is named as sun shield. And the main material used in the sun shield is something called Kapton. 5 layers of Kapton that are even thinner than a human hair are placed one after another to protect this shield. It is estimated that there are 300 million exoplanets exits in our Milky Way galaxy that are habitable. Basically, habitable planets are those planets which can provide basic blocks for humans living like Earth. Here's another question that comes up. How did James Webb manage to capture images of galaxies and stars so perfectly? And the answer is, James Webb consists of 2 infrared cameras. First one is near-infrared camera. Yes, NIRCam, and the second one is mid-infrared instrument, MIRICam. The NIRCam is used to capture short infrared wavelengths, while MIRICam is used to measure large infrared wavelengths. As science continues to progress, new inventions are emerging. James Webb is a major invention in space science, but you might be surprised to hear that an even more powerful telescope than James Webb is going to be built by 2027. If you want to know more about this, be sure to let me know in the comments section. With that, today's informative video comes to an end. I will see you very soon with another informative video. Until then, take care.